Hi guys, this is our lesson on 7.2, isosceles and equilateral triangles. You can take notes on a piece of paper in the textbook consumable if you have it, or you can make a Google slide. You can go into HMH and you can screenshot the PDF and you can create your own Google slide for your notes. So our essential question: what are the special relationships among angles and sides in isosceles and equilateral triangles? So if we look at an isosceles triangle, we have a picture here of it. We have the base at the bottom. We have the two base angles. We have legs on either side. And the vertex angle is pointing here. Okay, so an isosceles triangle is a triangle with at least two congruent sides. Congruent means same length. The two congruent sides are called the legs of the triangle. The angle formed by the legs is the vertex angle up at the top. The side opposite the vertex angle is the base at the bottom. The angles that have the base as a side are the base angles. In this activity, actually, we're not going to do that activity, okay? But this is from page 327. So let me just crop that out because you're not doing that. Boom. There we go. Okay, so proving the isosceles triangle theorem and its converse. In the Explore, you made a conjecture that the base angles of an isosceles triangle are congruent. We didn't actually do that, but in the book it's there. This conjecture can be proven, so it can be stated as a theorem. So this is the theorem. This is a main idea right here. Isosceles triangle theorem. If two sides of a triangle are congruent, then the two angles opposite the sides are congruent. This theorem is sometimes called the base angles theorem and can also be stated as base angles of an isosceles triangle are congruent. So that is the main idea, isosceles triangle theorem. We're going to prove the isosceles triangle theorem and its converse. So step one, complete the proof of the isosceles triangle theorem. So we have given segment AB is congruent to segment AC. We want to prove that the measure of angle B is congruent to the measure of angle C. That's what it says right here. Okay, so then our proof is organized in a table. What I'm going to do is add some text boxes over this to kind of go with it. All right, so statement one, the segment BA is congruent to segment CA. That's given. Okay, that's why. And then statement two is saying that the measure of angle A is congruent to the measure of angle A. So we're saying that a measure of an angle is congruent to itself. So the reason we can do that is because of reflexive property of congruence. Step three, the segment CA is congruent to the segment BA. The reason why, this is the symmetric property of equality. Step four, triangle BAC is congruent to triangle CAB because of side angle side congruence theorem. Step five, what we're going to put right here is that what we're trying to prove. Okay, the measure of angle B is congruent to the measure of angle C. And that's by CPCTC. Step 2, complete the statement of the converse of the isosceles triangle theorem. If 2 blank of a blank are congruent, then the 2 blank opposite those blank are blank. So we're just filling in from our theorem, basically. Okay, isosceles triangle theorem. So I'm going to come back here, and we're going to do some text boxes. We have angles. Triangle are congruent. Then the 2 sides opposite those angles are congruent. Step 3, complete the proof of the converse of the isosceles triangle theorem. So converse is in reverse order. So we're given the fact that angle B is congruent to angle C. So we're working backwards now. And that's what we have right above here. So we want to prove that the measure of AB is congruent to the measure of AC. Our proof is organized as a table. So our statements are on the left and the reasons are on the right. So statement 1 is that the measure of ABC, the angle ABC, is congruent to measure ACB. And that's just given, okay? That's just different ways of stating angle B and angle C, okay? We're just using the vertices to describe them instead of using their simple name of B or C. And then step 2, we're going to say that because of the reflexive property of congruence, segment BC is congruent to segment CB.